All right, so I had some people ask about question 5, proving some combination coefficients. So I have n plus 1 choose 2 is equivalent to n choose 2 plus n. And so sometimes it's nice to just write over here the right side of it in a different way. The right side is not n plus 1. The right side is just n factorial over n minus 2 factorial times 2 factorial plus n. Okay, so this is kind of my goal. I'm going to make the left side right now as n plus 1 factorial over n plus 1 minus 2 factorial times 2 factorial. And that becomes n plus 1 times n factorial, because I'm trying to match up my tops. And then n plus 1 minus 2 becomes n minus 1 factorial times 2 factorial. I'm going to cancel out a lot of terms here. N factorial over n minus 1 factorial can cancel out to leave me with n plus 1 times n over 2. Okay, so then let's expand that out a little bit more. Let's see. That's going to equal n squared plus n over 2. Let's see, how can I make that turn into what I want it to turn into? I want there to be an n factorial on the top. I can make this into n squared over 2 plus n over 2. So that's kind of close, but I somehow need there to be another n over 2 involved. This might feel a little bit weird, but this is a valid move. I can try this out. I could say that's n squared over 2 minus n over 2 plus n over 2 plus n over 2. You might be saying, what the heck are you doing, Mr. Maurer? I really just added the number 0 in the middle of my expression. And the reason I did that is because I was really wishing that this was a whole n over here on the side. And so now what I've done is I've really created a whole n over here, and I've created something else that I can play with over there. And so this will work out. This gives me n squared minus n, that factors a lot nicelier, over 2. And over here, I have n plus n over 2. So now we're really cooking. This becomes n times n minus 1 over 2, and this becomes 2n over 2. Almost done. N times n minus 1 is the same as n factorial over n minus 2 factorial. I'm just imagining all of the n minus 2, n minus 3, n minus 4, and so on canceling out, times 2 factorial, and 2n over 2 is equal to n, and we have proved the desired relation. On this particular problem, it's probably a lot easier to start with the right side of the expression of the equation and work it to match with the left side. So I'll just try to do it that way, just for funsies. So n choose 2 plus n. I could write that as n factorial over n minus 2 factorial times 2 factorial plus n. I can force there to be a common denominator. So I have n factorial plus n times n minus 2 factorial times 2 factorial. Actually, before I'm gonna cancel that out, I'm gonna simplify the first piece quite a bit first. So the first piece here simplifies to be n times n minus 1 over 2 plus n. Now it's a lot easier to make a common denominator of 2n over 2. That makes n squared minus n plus 2n over 2. That makes n squared plus n over 2. Factor out an n times n plus 1 over 2, and then bring in all the other terms. N minus 1 factorial, n minus 1 factorial, and then that becomes n plus 1 factorial over 2 factorial times n plus 1 minus 2 factorial, which is n plus 1 choose 2. So probably a lot clearer to go from the right-hand side to the left-hand side, but it works just as well the other way. Now 5b, let's see, what does 5b say? It says n choose 2 times, not plus, times n minus 2 choose k minus 2 equals n choose k times k choose 2. Lots of fun here. Okay, let's try this out. So left side becomes n factorial, n minus 2 factorial, 2 factorial. Then we have n minus 2 factorial. This is going to get a little nasty because I have to go n minus 2 minus k minus 2. So it flips around to be k plus 2. And then that's over k minus 2 factorial. Remember what our goal is. Our goal is this. So n choose k. I'm looking for that. What I notice is a minus and a plus cancel out. And then I see here this and this term are kind of like an n choose k. And this term cancels with this term. And then like these two pieces are kind of like not quite, but kind of like a k choose 2. In fact, all we need to finish out the k choose 2 is to multiply the top by k factorial, and then we just hope and pray that if we multiply the bottom by k factorial, that we get the desired expression. So I'm going to kind of rearrange things. On the top, we have n factorial and k factorial looking good. On the bottom, we have an n minus k factorial and a k factorial. So that's borrowing the purple k from the right side. And then we have a 2 factorial and a k minus 2 factorial. And would you look at that? The first chunk here is n choose k, and the second chunk here is k choose 2. Voila. Okay. Please send some comments and questions if you think anything that would help you.